Hello and greetings to everyone. We will continue from where we ended last time with 6, which is the highest common factor. Highest common factor, which is abbreviated as H.C.F, or another name for it is the greatest common divisor, which is abbreviated as G.C.D. Most often we always make use of highest common factor. So today we are going to see how to calculate the highest common factor of any given numbers. This is 6. We're going to write this down. Given the numbers 10, 15, and 20. To write down the factors of 10, we have negative 10, negative 5, negative 2, negative 1, 1, 2, 5, and lastly 10. To write out the factors of 15, we have negative 15, we have negative 5, negative 3, negative 3, then negative 3, we have negative 1, 1, 3, 5, and lastly 15. Next, the factors of 20, we have negative 20, negative 10, negative 5, negative 4, negative 2, negative 1, 1, 2, 4, 5, 10, and lastly 20. Now we are going to write down the common factors, that is the factors we see in the set of factors of 10, the set of factors of 15, and the set of factors of 20. The set of common factors of 10 and 15 and 20. This is how we denote it as F of 10 intersection F of 15 intersection F of 20. It will simply be equal to, we are going to look at the 3 sets. We are going to write down all the elements we see in the 3 sets. We have negative 5, negative 5, negative 5. Then negative 5, we have negative 1, negative 1, negative 1. Next, we have 1, 1, 1. And lastly, we have 5, 5, 5. Then we take a hyphen by the margin. The elements of the set of common factors F of 10 intersection F of 15 intersection F of 20 are called the common factors or common divisors. That's another name for it, called the common factors or common divisors of the numbers 10, 15, and lastly 20. Next hyphen, the set, you can see this is a set. The set negative 5, negative 1, 1, 5 is called the set of common factors or the set of common divisors, or the set of common divisors of the numbers 10, 15 and 20. Full stop. We write this down as, that means the way we write down the set of common factors or the set of common divisors, we write this down as d of 10, 15, 20. So when you see d of any given numbers as such, that means is the set of common factors or the set of common divisors. Continuation: any two numbers, m and n, we write down their sets of set. This is single set, not any set. We write down their set of common factors as, this is how we write down their set of common factors, d of m n. Now from d 10, 15, the set of common factors of 10, 15, 20, which is equal to, it has elements -5, -1, 1, must put the comma to separate the elements. Lastly 5. The highest element, remember we call the members of a set elements. The highest element is 5. If you compare all these numbers, 5 is the biggest. Therefore, 5 is the highest common factor. We denote highest common factor by using H.C.F, or the greatest common divisor of the numbers 10, 15 and 20. That is H.C.F. is how we denote it. The highest common factor of 10, 15, 20 is equal to 5. Or you can write it as such: the greatest common divisor of 10, 15, 20 is equal to 5. In general, we denote the H.C.F, the highest common factor, or the greatest common divisor of any two numbers, m and n, as, this is how we denote the H.C.F of m, n, or we denote it as such: GCD, the greatest common divisor of M and now let's take note of the following. Note the HCF, the HCF, HCF or GCD of any given numbers, any given numbers is a particular number, it's a particular number and not a set. You can see, for example, here the highest common factor of 10, 15, 20 is a particular number, which is 5. It is not a set. You take note of that. Now let's look at the various ways in which we can get the highest common factor for any given numbers. This is the first method we can use. You can either write out the factors, then next thing you extract the common factors, and from the common factors you get the highest. Another way of getting it is through prime factorization. Through prime factorization, we can easily find the HCF of any given numbers. Let's take an example. Find the HCF. Find the HCF of 24 and 96. Take down solution. We're going to see how we can apply the method of prime factorization to calculate the highest common factor of the numbers 24 and 96. First thing, we need to prime factorize the two numbers. 24 is equal to, if we divide 24 by 2, it gives us 12. 2 times 12, we know 12 divided by 2 gives us 6. 2 times 2 times 6. This will simply be equal to 2 times 2 times 6 divided by 2 gives us 3. 2 times 3. So this will simply be equal to 2 raised to the power 1, 2, 3 times 3. This is the prime factorization of the number 24. Next, let's prime factorize the number 96. We know 96 divided by 2 gives us 48. This will be equal to 2 times 2. We know 48 divided by 2 gives us 24. This will simply be equal to 2 times 2 times 24 divided by 2 gives us 12, which will be equal to 2 times 2 times 2. 12 divided by 2 gives us 6, equal to 2 times 2 times 2 times 2 times 6 divided by 2 gives us 3. So this will simply be equal to 2 raised to the power 1, 2, 3, 4, 5. 2 raised to the power 5 times 3. Next thing now, for us to get the HCF of the numbers 24, 96, it will simply be equal to, we are going to look at the prime factorization of the two numbers 24 and 96. We are going to see that the prime factors 2 and 3 are common in the factorization or in the prime factorization of the two numbers. We are going to write down the prime factors with the smallest powers. We are going to write down the common prime factors with the smallest powers. You can see 2 is common, 2 is common. So we are going to write down 2 with the smallest power. It is 2 to the power 3. Then we are going to multiply it with the next prime factor, which is common in the two numbers. 3 is common. And 3 is to the power 1. So we are going to multiply by 3 to the power 1. So this will simply be equal to 2 times 2 times 2. We know 2 is to the power 3. 2 times 2 times 2. Then times 3. So this will simply be equal to 2 times 2 gives us 4 times 2 is 8. 8 times 3 gives us 24. Therefore, 24 is the highest common factor of the numbers 24 and 96. We can also, this is another method we can use in calculating the H.C.F. We can also use the method, of, I will call it common division. That means we divide the two numbers by a prime factor which is common to the two numbers. We can also use the method of common division to find the H.C.F. of any given numbers. Let's take an example. We are going to answer the example above using this method. Find the H.C.F. Find the H.C.F, the highest common factor of 24 and 96. Take down solution. So you'll be the one to choose the method you best understand. If you can memorize all the methods, if you can master all the methods, then that will be good. First thing, for the first column, we are going to put the prime factor which is common. The second column, we are going to put the first number 24. For the third column, the second number 96. Looking at these two numbers 24 and 96, we know they have a prime factor, a common prime factor of 2. We are going to write 2 here. 2 divided by 24 gives us 12. We're going to write down 12. 2 divided by 96 gives us 48. We bring down 2. 2 is still a common prime factor to 12 and 48. 12 divided by 2 gives us 6. 48 divided by 2 gives us 24. 2 is still a common prime factor to the numbers 6 and 24. We bring down 2. 2 will go into 6 3 times. 24 divided by 2 gives us 12. Now at this level, you will see that 3 is a prime factor which is common to 3 and 12. So we are going to write 3 here. 3 will go into 3 1 times. 3 divided by 3 gives us 1. 12 divided by 3 gives us 4. So we are going to end here at this level because there is no prime factor which is common between 1 and 4. We are going to end here. And from here, at this level now, it is very easy for us to find the highest common factor. So our highest common factor of the numbers 24 and 96 will simply be equal to, we are going to multiply all the numbers we have at the first column. 2 times 2 times 2 times 3. This will simply be equal to 2 times 2 gives us 4. 4 times 2 gives us 8. 8 times 3 gives us 24. You will see that the results are the same. Now let's take down exercise application. Exercises for application. Goes for question 1. Find the following. A. We have to find the H.C.F of the numbers 20 and 45. For B, we have to find the H.C.F of the numbers 150 and 250. For question C, we have to find the H.C.F of the numbers 9, 27 and 81. Question 2 says we should find the following. For A, we have to find the H.C.F, the highest common factor of 2 raised to the power 2 times 3 raised to the power 3 times 5 and 2 raised to the power 3 times 3 raised to the power 2 times 5 raised to the power 3. We go to question B. We have to find the greatest common divisor of 2 raised to the power 4 times 5 raised to the power 3 times 7 raised to the power 2 and 3 raised to the power 3 times 5 raised to the power 3 times 7. For question C, you have to find the H.C.F of 3 raised to the power 2 times 5 raised to the power 3 and 2 raised to the power 3 times 3 raised to the power 2 times 5. And lastly, we have 2 raised to the power 1 times 3 raised to the power 3 times 5 raised to the power 2. These are the questions we have to answer. We're going to take down solution. We answer the questions. Solution. Question 1A. We have to find the H.C.F of the numbers 20 and 45. So we can use any of the methods. For this first question, I'm going to make use of the method of prime factorization. So we take the first number 20. We know 20 is the as 2 times 10, which is equal to 2 times 2 times 5. So this will give us 2 raised to the power 2 times 5. If we take the next number 45, we know 45. First prime factor of 45 is 5. We know 45 divided by 5 gives us 9. So this will give us 5 times 9, which is equal to 5 times 3 times 3. So this will simply give us 3 raised to the power 2 times 5. This is the prime factorization of the number 45. Now for us to get the highest common factor of the numbers 20 and 45, we are simply going to look at their prime factorizations here and here. We identify the prime factors which are common. 5 is common, 5 is common. Then we are going to write down that prime factor with the smallest power. 5 is 5 here is to the power 1, 5 here is to the power 1. So the H.C.F will simply be 5. We are done. We go to question B. Question B, we have the numbers 150 and 250. In this case, let's make use of repeated division. So at the first column, we are going to make use of a prime number, which is a common factor to 150 and 250. We know we can make use of 2. 150 divided by 2 is equal to 75. The next, 250 divided by 2 is equal to 125. 75 and 125, a prime factor which is common is 5. So we make use of 5. 75 divided by 5 is equal to 15. The next, 125 divided by 5 is equal to 25. So that we can still make use of 5, we bring down 5. 15 divided by 5 gives us 3. 25 divided by 5 gives us 5. We are left with two prime numbers, 3 and 5. Between 3 and 5, there is no prime factor which is common. So we are going to end at this level. Then we conclude, therefore, the H.C.F, let's do the conclusion by this side, the H.C.F of the numbers 150 and 250 is simply equal to, you're going to multiply all the numbers we have at the first column, 2 times 5 times 5, which is simply equal to 2 times 5 gives us 10. 10 times 5 is equal to 50. So 50 is the H.C.F. Next, we go to question C. We have to find the H.C.F of the numbers 9, 27, and 81. In this case, we are going to have 4 columns, 9, 27, 81. First, we need to get a prime factor which is common to these three numbers. We can make use of 3. 9 divided by 3 gives us 3. 27 divided by 3 gives us 9. The next, 81 divided by 3 gives us 27. We can still make use of 3. 3 divided by 3 gives us 1. 9 divided by 3 gives us 3. 27 divided by 3 gives us 9. At this level, we have 139. There is no prime factor which is common. So we can conclude, therefore, the H.C.F of these three numbers, 9, 27, 81, is simply equal to 3 times 3, which is equal to 9. And we are done with question 1. Now we move to question 2a. We are to find the H.C.F. In this case, the numbers have already been prime factorized, so it is very easy for us to get the H.C.Fs. 2 to the power 2 times 3 raised to the power 3 times 5. The next one, 2 to the power 3 times 3 raised to the power 2 times 5 raised to the power 3. In this case, the H.C.F of 2 raised to the power 2 times 3 raised to the power 3 times 5, 2 raised to the power 3 times 3 raised to the power 2 times 5 raised to the power 3 will simply be equal to, we are going to look at the two numbers, then we identify the prime factors which are common. 2 is common, 3 is common, 5 is common. Then we are going to write down the prime factors which are common with the smallest power. 2 is common. Here 2 is to the power 2, here 2 is to the power 3. We are going to take 2 to the power 2. We multiply now by 3, which is common. Here 3 is to the power 3, 3 here is to the power 2. We multiply by 3 raised to the power 2 times. Here 5 is to the power 1, here 5 is to the power 3. So we are going to multiply by 5 raised to the power 1. So this will simply be equal to 2 times 2 times 3 times 3 times 5. 2 times 2 simply gives us 4. 4 times 3 is simply equal to 12. 12 times 3 gives us 36. 36 times 5 gives us 180. In this case, this is our H.C.F. The highest common factor of these two numbers is 180. In some cases, you can decide to leave the H.C.F at this level, but it is always good to simplify it. Next, now we go to question B. B says we should find the greatest common divisor of 2 raised to the power 4 times 5 raised to the power 3 times 7 raised to the power 2. The next one, 3 raised to the power 3 times 5 raised to the power 3 times 7. Yes, answer the question. 2 raised to the power 4 times 5 raised to the power 3 times 7 raised to the power 2, 3 raised to the power 3 times 5 raised to the power 3 times 7. It will simply be equal to, first thing we need to identify the prime factors which are common. Here we have 2 to the power 4. Here there is no 2. Here we have 5 to the power 3. 5 to the power 3. So 5 is a prime factor which is common. 7 to the power 2. 7 to the power 1. 7 is a prime factor which is common. So we are going to take 5 raised to the power 3 times 7 raised to the power 1. This will give us 5 times 5 times 5 times 7, which is simply equal to 5 times 5 gives us 25. 25 times 5 gives us 125. 125 times 7 gives us 875. So this is the H.C.F of the two numbers. Now let's answer the last question, question C. We have been given, we have to find the H.C.F of 3 raised to the power 2 times 5 raised to the power 3, 2 raised to the power 3 times 3 raised to the power 2 times 5. Next, 2 times 3 raised to the power 3 times 5 raised to the power 2. Let's answer the question. Two raised to the power 3 times 3 raised to the power 2 times 5. 2 times 3 raised to the power 3 times 5 raised to the power 2. So this will simply be equal to, the first thing we need to identify the prime factors which are common. 3 is here, 3 is here, 3 is here. We are going to take 3 with the smallest power. It will simply be 3 raised to the power 2. We multiply by the next prime factor which is common. We have 5 to the power 3. There is 5 to the power 1. 5 to the power 2. So we multiply by 5 to the power 1. Next, there is 2 here. There is no 2 here. There is 2 here. So we end at this level. This will simply be equal to 3 times 3 times 5, which will simply be equal to 3 times 3 gives us 9. 9 times 5 gives us 45. 45 is the H.C.F of the three numbers. We are done with the correction of the exercise for application. If in case you have any worries, make sure you leave your questions at the comment section. Please, you like the video, you share, and please do not forget to subscribe to this channel. Thank you very much for watching.